Hello, and very warm welcome to my courses. I have designed 4 different courses here, which systematically from course number 1 to course number 4, they have something in mind that they are just going to expose you to scientific analysis. On the first course, you are going to be exposed to the basics and fundamentals of the non-Bayesian regression analysis. This course, course number 1, has been designed for those students who have never tried the non-Bayesian regression methods, either in their research or they have never been exposed to that academically. We're just going to use the R and the R Studio and some internal data sets in the R to just do some fundamentals and basic regression analysis and do some model comparisons. However, at the second course, you're just going to be exposed to one of the most interesting methods in regression analysis, which is going to be the fully Bayesian methods. We're just going to compare. In this course, you're just going to be exposed not only to the Bayesian methods in regression analysis, but however, at every single step, you're just going to do the same analysis in the non-Bayesian framework. And you are getting a chance to compare these 2 methods to see that how these methods are going to be different. I have designed the course number 2 essentially from A to Z, that it enables you to run the Bayesian regression analysis for your research projects, or if you are just working in an industry, to apply the Bayesian regression methods using the R in order to find interesting results and conclusions. However, more interestingly, at course number 3, I have designed this course only with that design in mind, that you're going to get exposed to one of the most interesting probabilistic programming languages, which is going to be the STAN, which uses Hamiltonian Monte Carlo in order to do fully Bayesian analysis. You're just going to be exposed from A to Z how to just write a STAN model, how to incorporate that into your frameworks and check for the convergence, and even we have done some logistic regressions using the STAN as a probabilistic programming languages within the fully Bayesian framework. And you're going to be able at the end of that course to use STAN in your research, or if you're working in industry, to just use that interesting language, programming language, to find interesting and brilliant results. However, very interestingly, for course number 4, I have tried to incorporate every single thing that we have learned from course number 1 going to course number 4, incorporating all the non-Bayesian regression analysis and the Bayesian regression analysis by using the STAN programming languages to discuss about a very unique and groundbreaking research about the Alzheimer, how to see, and you're going to see how you can just use the Bayesian frameworks by using the STAN probabilistic programming language in order to predict and analyze, I should say, the brain volume and the brain atrophy from the age of, I should say, for example, 60 all the way going to the age of, let's say, for example, 90, to see that how the brain atrophy and the reduction of the brain sizes can be predicted and modeled using the Bayesian by writing some codes in the STAN using the R, which is going to be a very interesting project, which you're just going to incorporate all the things that you have learned from course number 1, which is the non-Bayesian regression analysis, all the way to course number 3, which is going to be writing a Bayesian model within the STAN in order to predict the brain volume reduction after the age of 60. But however, we are just going to use a hierarchical models in the Bayesian context, which is going to be a very interesting topic, and it's going to be essential these days within the research environment, from, I should say, from the life sciences to many other fields, even the industry. At the end, I hope that by completing these 4 courses, particularly the Alzheimer's disease analysis using the Bayesian hierarchical models in understand, you should be able to just conduct brilliant researches if you are a graduate student, or get interesting results if you are a practitioner in the industry. I can't wait to have you just in my courses, and I wish you best of luck and hope that you enjoy these courses then. Enjoy reading Bayesian, and I hope that you think Bayesian and act Bayesian in these 4 courses then. Thank you, and see you in the courses then.